What excited me the most about coming to work at NASA was that it was for NASA. As a microbiologist, as an undergraduate student, I didn't realize that there were opportunities for microbiologists. And once I started working as an intern, then it was a foot in the door. My name is Jesica Navarrete. I am a fourth-year graduate student, a PhD student at the University of California, Santa Cruz. My research is about using microorganisms to dissolve e-waste for the purposes of recycling. How this process works is that we can take the genetic abilities of, say, sea sponges, who already make enzymes that naturally dissolve and rebuild glass. Taking the genetic information that encodes for that, we can put it into a bacterium to mass produce these kinds of enzymes, these glass dissolving enzymes, and so we can use those enzymes to break down e-waste. This type of research is not without its challenges. So what we're using are host bacteria to make these enzymes or these proteins that they don't normally make. So they want to live and do what the bacteria do, and we want them to kind of work for us. So to do that, we'd modify their genome. How we do this is we can take a lot of the methods already developed in biomedical research, which is how they treat cancer and disease, and apply them to these types of organisms. They're very effective in, modifying the genetics of the microorganisms so that they're more amenable, they're more able to take our, instructions, our genetic instructions, and make the constructs that we want them to make. Some of the challenges that we run into with this type of research are very much along the lines of any biotechnology research, and that is scaling up and rate. One of the great things about working at NASA is that we work with world-class researchers, engineers, and other scientists working on these problems, solving some of the engineering questions like how big a bioreactor do we need, how much material can we produce with a certain amount of space or resources, what kind of conditions need to be engineered or kept, because these microorganisms can't be too cold, they can't be too hot, how much water do we need. All of these are issues that different teams work on, and they all come together to make this one project a reality. My research at NASA relates directly to what I'm studying at school because they're one and the same. My project here at NASA is my dissertation project as well. So the impact of this work on potential missions at NASA is hopefully it will influence mission concepts. So if we have the resources available on Mars, using microorganisms, we can take metals from the volcanic rocks that are there. If another student were considering applying to the STI internship, I would tell them to definitely go for it. NASA is a fantastic place to work, and it's an inspiring place to work. It would be a great opportunity for a student, a great experience.